Alrighty, folks, we're going to go into more terminology on lab scopes. I've got another one coming up fairly soon. I want to break them down to bite-sized chunks. So let's go ahead and get started. All right. So the ones I'm going to be covering this time is going to talk about the shape. We'll talk about the pulse width. We'll get into patterns and relationships, and then we'll get into some cursors. All can be very beneficial if your lab scope supports this, and most lab scopes do. So this is actually a shape. This is a digital shape. So you have that up and down rise, and this is makes it really unique to that particular sensor that you have. Like you could have a actual digital camshaft or crankshaft sensor. These are like your Hall effects. So this is really important to understand how they relate to each other, so you can see a very consistent shape of the pattern. And then we have what we call pulse width. This is where we're going to turn something on and off. You can actually see where this is actually turned on, where it drove the voltage down, and we can actually measure the amount of time in between the on and off time. And you can actually see the pull down, okay? So in other words, turned on, and then it was relieved, and then you actually see that voltage spike going on to this. This is like what you might find in a fuel injector. Then you can actually have that too. So using relationships, like maybe you want to see the relationship between the camshaft and the crankshaft sensor. And remember, the cam and the crank have a 1-to-2 relationship, so they should be quite a bit different. So this is another way of looking at it. And then, of course, cursors. Now, this is where you can actually map out, like when a pattern begins at maybe you have a wheel speed sensor that is an AC signal on it, and then to measure it across to see where the cycle begins and cycle ends, or maybe that's not a really good one, maybe a camshaft signal. And there you can actually measure how much time in between. So this is kind of a way of calculating and figuring out if this sensor is correct or bad or good or whichever. As long as this one, you can actually do it on your digital signals too. This is actually showing the beginning of like a camshaft, I should say a crankshaft sensor, and the crankshaft sensor is actually has maybe a missing tooth to it. And this is actually showing the beginning to the beginning again. So it gives you the amount of time, like 84.67 milliseconds. So it's a good tool when you're measuring electrical signals. So this is what I want to do really quick, like just get you familiar with them. And some of the stuff you can actually do, and I'll be breaking down with this actual lab scope later on. And then I'll show you how to do some of these actual measurements and all. So this is going to be fun. All right, that's all for now. Take care. If you like this, please like and subscribe. That would really help me out. And we'll see you in the next video. We got some more special terminologies going on for lab scopes. Bye for now.